Hello students, so we're on our second to the last chapter of the semester. This chapter is a lot like chapter 5, it's very long and there's a lot of new concepts, and so I'm going to try to explain this chapter in more detail compared to chapter 6 because I think that'll be really beneficial for us. And so I'm going to go through each slide, and then after I create these videos I'll just combine them into hopefully one big video for you all to look at. So chapter 7 is all about surveys and looking at different survey sampling methods, learning about the world using a survey. And so to begin, let's look at some survey terminology. So the note packet that I have provided does give you an outline of, or a note-taking outline that you can fill out to follow along. So looking at survey terminology, the first term that I want to introduce is a population. So back in chapter 1 and 2, we did talk about population and sample a little bit, but we're going to be revisiting that because that's the basis to this chapter. So a population is a group of objects or people we wish to study. And so when we say a group of objects or people, we're referring to a whole group. We're not just talking about a subset of the group, but we're talking about all of the objects or people that fall into this group. The second term I want to talk about is parameter. So the term parameter refers specifically to the population. So parameter is just basically a numerical summary or a numerical summary or value that characterizes some aspect of the population. So this is going to be a number that describes all of the people that you're interested in studying. So something like the average age of all of the people in Bowling Green, something like that. And then the third term I want to talk about is a census. So again, the word census here connects to parameter and connects to population. Parameter connects to population because this is a numerical summary that characterizes some aspect of the population. Now the census is a survey in which every member of the population is measured. So the census refers specifically to the population, and the census refers to the parameter because the parameter is about the population. So these three terms, I do want you to keep them in mind that they connect with each other. So a way to remember this is parameter is for a population, P and P. This next slide right here, we're going to talk about a whole different part. So the first term I want to talk about for the slide is a sample. So I introduce a population. We know that a population can contain samples. And so just to briefly remind you, a sample is a collection of people or objects taken from the population of interest. So if our population was the whole United States, then Ohio would be considered a sample. If my population was all of the Math 1150 students at BGSU, then my sample would be one class or one Math 1150 class out of all of the Math 1150 class at BGSU. Now the next term, a statistic. So we have a parameter. A parameter relates to a population because it describes a numerical value about the population. Now the statistic, also known as an estimator, is a numerical value that characterizes the sample. And so the statistic is specifically for the sample. The parameter is specifically for the population. The next term would be an estimate or estimates. So estimates are just numbers that come as a result of statistics. So we'll look at examples of each of these terms to make it easier to understand what I'm trying to say. But it's very definition heavy, so I highly recommend getting a good grip of these definitions before moving on. The final definition that I want to introduce is statistical inference. So the whole goal of this chapter is to be able to make a statistical inference. And when we say statistical inference, this is referring to the art or science of drawing conclusions based on about a population based on the sample data. So sometimes it's really hard to be able to receive a survey response from everyone in our population of interest. So instead, we rely on samples instead. And so based on these samples, we want to make a conclusion about the population. And so that refers to statistical inference. So being able to go from a sample and generalizing it to a whole population. So I'm going to compare and contrast statistic with parameter and kind of highlight some of the common examples that we have. Okay. So a statistic is one that can be computed based on data. Whereas the parameter is typically unknown or just provided to us. The reason why a parameter is unknown is because a parameter describes the population. It's very hard to be able to gather data or information on every single thing, person, or object in a population. And so parameters are usually unknown or given to us, whereas a statistic, we can actually collect data and be able to calculate what the statistics would be. Some common examples would be the sample mean. So we introduced the sample mean in chapter 3, which is X bar. This X bar, or this mean right here, is referring to just a subset of the population. We also introduced the sample standard deviation, which we called little s. Again, this is specific to a sample only. And then now this new statistic is the sample proportion, which has this look right here, P with a little hat on top, so we call it P hat. This is the one that we'll be focusing on specifically for this chapter, so the sample proportion. So now let's look at some common examples for parameter. So if we have the sample mean, we have the population mean too. And this notation was introduced to us in chapter 6. Chapter 6 was all about the population. Chapter 3 was all about the sample. If we have a sample standard deviation, we also have a population standard deviation, which in this case is sigma. Again, this was shown to you in chapter 6. Finally, if we have a sample proportion, we have a population proportion. The population proportion is denoted as just P without the hat. So the hat here will always indicate that this is just a statistic or an estimate. Okay, so I lost my spot, so let's go back here. So this first example right here, we're told that 500 college students with a GPA higher than 3.0 were surveyed to see how long they study on average. The study reveals that these students study 10 hours on average. So the point of this example right here is to get you familiar and comfortable with identifying the sample, the population, being able to find the statistic or the parameter, and finally being able to make a statistical inference. So we're connecting all of the, or some of the terms that we went through in this example. So the first thing I want us to look at is identifying the sample. So when we're given a problem like this, can we identify the sample that we're working with? The way that I like to identify the sample is by looking at the group of people or objects that are being studied. So in this case right here, the people that are being surveyed or studied are the 500 college students with a GPA higher than 3.0. So that would be my sample for this problem. So the sample consists of the 500 college students. And it's very important to note that these 500 college students have a GPA higher than 3.0. So now that we have our sample, we want to look at the population. And this is very easy to do because if we have our sample ready and we know that the sample comes from the population, then we can just make a generalization on what the population may be. So if the sample consists of the 500 college students with a GPA higher than 3.0, then the population should be all college students with a GPA higher than 3.0. So the population for this problem would be all college students with a GPA greater than 3.0. So the next thing I want us to look at is what is the statistic that is being measured or studied in this example? And what is the value of our statistic? So again, a statistic is a numerical summary that describes some aspect of the sample. We have 3 examples. We have the sample mean, the sample standard deviation, and the sample proportion. Out of these 3, which one is the one being studied? And I hope you answered the sample mean, because here we're looking at the number of hours they study on average. So the word average already tells us that we're looking at the mean. So the statistic that is being calculated here is X bar, or the sample mean, and then do we know what the value of our statistic is? Or do we know what the sample average number of hours are for these students and how long they study? Yes, we do. So X bar in this case is 10 hours because we know that these students study 10 hours on average. Okay. So the next thing we're looking at is a parameter of interest, which I already filled out. So the parameter of interest is the population mean. We don't know what this value is because it's usually unknown or just provided to us, but we do know that what we're trying to figure out is a population mean because what the study focuses on is the sample mean. So we want to use the sample mean and be able to make a conclusion about the population mean. So whenever the sample mean is being calculated or measured, then we're always looking at the population mean. If we're looking at the sample standard deviation, then we're going to be looking at the population standard deviation. If we're looking at the sample proportion, then we're trying to make a conclusion about the population proportion in the future. Finally, being able to make a statistical inference on the population based on our statistic. So based on our statistic, we know that these 500 college students with a GPA greater than 3.1 study 10 hours on average. And so using this information, what is a conclusion we can make about the population? So a conclusion we would make is that based on the sample, we can expect that all college students with the GPA higher than 3.0 study 10 hours on average too. So based on the sample, we can expect that all college students with a GPA higher than 3.0 will study 10 hours on average. So we're using what we know about the sample here, and we're making a conclusion about the population. So in this next example right here, I want you to go ahead and try to answer these questions. It's going to follow the same format, except that you're doing it on your own.